Okay, so let's start with like throwing some meat at this problem. What are neural networks? So the core idea is that you start with a let's say a kind of a definition here, like computing system made up of a number of simple, highly interconnected processing elements, and they each one processes information by dynamic state in response to an external input. So this is still very true. They didn't change much at the core. They were, as I said, inspired by biological networks. Important point, they learn by example. And here I want to introduce this term. I don't know who heard of it. Neural networks as differentiable programs. By differentiables, I mean, derivatives, as in calculus. So the idea here is that when you write your program, you don't write exactly what to do. You don't like a rule like if this is greater than 2, do this. If it's less than 2, do that. But you write it with a parameter, like a free parameter. Like if this is greater than x, do this, or do y. And if it's lower than x, do z. And x, y, and z, they are defined by the data. And the differentiable part is because, of course, you want to find, you want to minimize the error on your training data, and to do a minimization, we use the usual trick of taking derivatives. So it's something a bit strange to think about it, but you're writing a program and then you're taking the derivative of the program respect to its parameters. So it's a bit abstract this way. So let's take a step back and look at this in more details. Okay, so let's start very simple. Functions and derivatives. I assume most of you are familiar with the concept. So just a extremely quick refresh. So function is basically a relationship between like two sets. So you take an element of one set and you map it to an element of another set. In this case, we have, for example, like real numbers. I take a number and I get the square of that number. So I can do function applications. So yeah, here I'm using a notebook, so this kind of works real time. I can apply the function to many elements and plot it. And from calculus, we know that if you want to measure how much the function changes at any given point, like I move from here to here, I move like linearly of one step. How many steps I move on this other axis. So this is what the derivatives is, as first order approximation is telling me. So in mathematics, I can do it symbolically. So I can say f prime of x, and given that f was x squared, quite simple. Now we know this is 2x now. And I can actually compute it. And this is nice because the derivative, I can measure it at the point, but I can also define it as a function. And if I have a function, it's straightforward to compute it. I don't have to take like any limit or anything like that. I just have the definition. When I have a closed form for the derivative, and I'm repeating, this sounds stupid, but I'm repeating this because it's really important for what we are going to see later. When I have a closed form function for the derivatives, I can just put something in and get the value. Okay, so as I said, like we are going to take derivative of programs. So let's look at somewhat more like unusual derivatives. Yeah. So like something like an if statement. An if statement, you can see it as a more mathematically as a piecewise function. And if I frame it this way, is kind of clear how I take the derivative of a piecewise function. Like it's piecewise continuous. Like I have a problem with some boundary condition, and taking from what I was saying at the beginning, is not very important. In calculus it is, but in neural networks it's not very important what I use for my boundary condition. I can set one of the two. I can set something in the middle. Something of size 0 as a single point shouldn't really be that important. So there are a lot of cut corners, mathematically speaking, in neural networks. So don't worry about this stuff. But this is useful to show that even something that is strictly speaking non-differentiable for the purpose of finding an optimum for my training, there are no problems. So if I process some numbers and have an if statement, I just take the derivatives over 2 and that's it. I'm happy with the result. And so you can imagine, we pile up those things and we take derivatives of more complex programs by taking the derivatives which step, basically. Okay, so what do I use this function for in the setting of machine learning? I want to make predictions. Yeah, like I have a function based on parameters, and I want to predict something with those function and parameters. Let's go concrete with a very simple example, like classical linear case. So I write it this way, like in a more like verbose way, because now I have like my function f now is f of a and b, and I apply this, or alpha and beta actually, and apply this to x. So this is to say that my function f is not really complete. F is complete only if I specify alpha and beta, and this is in this case my very trivial linear model. So now this is a model of reality. If I put something in, I get something out, and what I get out really depends on and can drastically change based on, in this case, only 2 parameters that I set. Yeah, and of course, given a particular choice of parameters, I can put something in, and I here, and I get something out here. So let's start with this very simple setup. Now, oh yeah, here I use this like what is called a regression example, but in many cases with neural networks you do classification, so you find discrete values. Is this an issue? No, not really. You typically, the usual trick is that you use a mathematical function like the sigmoid to constrain your output. So this is this generalized linear model, strictly speaking. I take my linear model and I process it with some nonlinear function, and now I just put a threshold, and I say, for example, like if the result of this, now the model is like this, and I can say if my if the value here is above 0.5, I say class A in this case. If it's below, I say class B. So now that here I classify as A, here I classify as B, and again, changing the parameters is changing my classifier. So this is a very simple classifier that is saying A or B, sorry, depending on my parameters. So we have like these 2 basically big class of tasks: regression and classification, continuous and discrete.